So I'm Matteo Giuliani, an assistant professor at Politecnico di Milano, and my main role in CLINT is studying droughts, and specifically how this type of extreme event is impacting on two of the four climate change hotspots, so the Lake Como system and the Zambezi watercourse in Southern Africa. The Lake Como is considered an hotspot related to the category of snow-dependent river basin, because indeed most of the water that flows into Lake Como comes from the Alps and the snow that is accumulated over the winter time and then melts in spring. So this makes, let's say, the traditional classification of this case study as a climate change hotspot, because the snow dynamics is one of the processes that will be mostly affected by climate change. So we are already observing actually in this system a change in the hydrologic regime due to the fact that temperatures are growing, and so there is less and less snow accumulated in the mountains during the winter period, and then more water is coming in spring because snow is melting earlier and quicker. And so this makes the case study particularly relevant to study how droughts are currently hitting the system and will impact on this system in the future. Value because drought management in this region of Italy is not extremely developed, because the problem related to droughts are somehow emerging over the last 10 years because of this ongoing trend of the growing temperatures. And so there is a lack of understanding about the main drivers of droughts, and here is where CLINT, with the use of machine learning and artificial intelligence, can contribute the most. And on top of this, we are in strict collaboration with the end users of the system, so we can directly test also the added value of the climate services informed by artificial intelligence in terms of making societal impacts on the system by making a more proactive management of extreme droughts. The outcomes of the project in terms of enhanced climate services will have a direct impact on the operation of the lake, because indeed there is the Consorzio dell'Adda, who is responsible for the operation of the dam that distributes water to a variety of users. And we already know that better forecast, better climate projection can enhance the efficiency in the operation of this system. So we do expect to transfer our output directly to this end user, who can start using our enhanced forecast for their decision-making purposes. And ultimately what we expect is that we will produce gains for the end users because of a better water supply reliability. Downstream of Lake Como there is the extensive agricultural area served by the Adda River in the Pianura Padana. And so this is mostly irrigated agriculture. So if we know in advance that a drought is coming, the operator of the lake will be able to better distribute the water, ultimately providing better support for the cultivation of crops, and so higher yields and higher profits for the farmers downstream. And besides, the lake itself is suffering during droughts of low water levels that impact navigation and touristic activities in this area. And so again, a better management, especially during the drought condition, can support all these multi-sectoral activities that rely on the water level of the lake.